Hey, we are back live again. We were just here just 20 minutes ago now, and we are back here again with another
Back
awesome
again.
workshop. Absolutely. This has been a whirlwind of content. There is so much great stuff. We've had proximity on once before. We had Matt Locke here talking about chain abstractions in general, but we have an awesome workshop for you today. Owen, you want to kind of introduce what we're going to be doing today?
The topic is Bitcoin, and not just Bitcoin by itself, but Bitcoin with NEAR and how you can use NEAR and chain signatures to do more on Bitcoin. But I won't spoil anything. I think we can let the devs speak for themselves. They can probably speak better about it than I can.
Yeah,
So
yes. Let's get them up here. So today
get
we
them
have
up.
Greg and Edson from Proximity. Thanks, guys. Thanks for coming on DevHub Live.
Hey guys.
Hi, thank you for having us.
Our pleasure. Our pleasure. So, let's talk a little bit about kind of what you guys have in store for us for the workshop today, and wherever you want to get started.
Yes, so I'm going to start, and I'm going to share with you guys how some of the strategies that we are working on in order to develop in BTC, because let's be honest, developing in BTC is super hard. But right now, I think we are coming up with some strategies that are going to make super easy for developers to create apps with NEAR and Bitcoin.
Awesome. Yeah, and if you want to share your screen, feel free to do that as well.
Okay.
Yeah, I was playing with some Bitcoin a few months ago, and I had never really like touched it before. And then I was like, wait, I have to sign all these UTXOs, and I got confused, and then gave up. So
Yeah,
I'm
exactly.
excited to learn more here.
Can you guys see my screen?
Yeah, we'll bring it up. There we go. Infinite. Perfect.
Ooh.
Okay.
Yeah, I can. There we. Literally me.
So this is yeah, I mean, we know developing in Bitcoin is super hard, and yeah, that's Owen. And right now, in order to explain, yeah, just to create a small mental model what we are gonna do. So basically, we have in some of the tooling that exists in the Bitcoin world is the Bitcoin Core node, but they have a particular modality called the REDACTED mode that basically allows you to run a Bitcoin node locally in developing mode, and you can do things like generate new addresses, move blocks, and mine some Bitcoin to that particular address, and that's very helpful. But there are other particularities here because we have the MPC signer in here, and this is living basically in two places right now. We have a testnet where we have this MPC signer and we can request signatures, and also the mainnet. So how do we do something with these two pieces in order to facilitate the developing of BTC apps? In particular, because like Owen mentioned, one of the main problems with the BTC world is the faucets. How do you get bigger amounts? How you can create more UTXOs and test more complex scenarios? So yeah, but the cool thing about this is that you literally can sign in the MPC signer side, and you can propagate that transaction to the BTC node in REDACTED mode in your local computer. So because the signatures created by the MPC signer are valid in the BTC node. In that way, you can basically derive the address of your NEAR smart contract, give some UTXOs to that address. You can give any amount of UTXO that you want, and then basically sign that you want to spend some amount of money, and you propagate in this BTC node. So I'm going to show you how I'm currently working with that, and the best place to look at that is the Omni library. If people is aware what is the Omni library, The only library what we are trying to do is a small set of utilities, and like the name says, a library where you can create transactions for multiple blockchains. Right now we support Bitcoin, EVM in this case for Ethereum, and for NEAR. So what you can do is essentially within a NEAR smart contract, you can create a payload of a transaction and immediately sign with the MPC signer. And then you simply return the payload that is already signed, and you can propagate that to the different networks. So in order to ensure that this encoding is working, we have this set of integration tests in the test folder. So we have for EVM, for NEAR, and also for Bitcoin. And here I'm going to walk through a bit how what I explained before here is helping us to ensure that what we are doing is correct. So like I mentioned, we have well, we are using actually some tooling from Bitcoin. There is a ROS Bitcoin implementation. It's still it's very useful, but it's still under development. But still is what they have is very useful for us, and it's been saving our life. So we are basically, what we do here is we set up the Bitcoin node, and what it's doing is literally downloading the Bitcoin core node and running behind the scenes. I thought the other day that there might be something about security, because I'm basically downloading a Bitcoin core node and executing it. However, you can just you can install the Bitcoin core node in your computer, and this utility will recognize that it's installed, and then it's just going to run it in rep test mode. And then we just create an instance of that particular client, and we can do things like set up an account for Bob and another for Alice. Here, in this particular example, this is for pay to witness public key hash. And you basically can set up accounts for different type of address, because in the BTC world, we had these different types of addresses. Right now, we support this Beach 32, which is the ones that are used for set-with transactions in BTC. But we also have support for legacy transactions. And then we generate blocks to a particular address. In this case, I'm giving UTXOs to Bob. And then I basically have some helpers to get, okay, I already gave UTXOs to Bob, and I'm not limited to do this. I can do more, generate more UTXOs, and as I wish. And then
so in this environment, are you able to like control the economy then, and like how many UTXOs and whatnot?
Yeah, exactly. And you can assign to any particular address. So right now, I'm just assigning to Bob. And here, this is something, because in order to have, there has to be 100 blocks propagation. So there has to pass, confirmation blocks. So that's why we have 101. But after 101 blocks, Bob is going to have UTXOs. And this is how then I access. And in this case, because this is a very simple example, I'm testing with a single UTXO, and then I get the UTXO. And this is these functions. There are some wrappers. We are actually working also in what we call omni-testing utilities, where we are going to encapsulate all this logic that we are adding here. Like, you're going to be able to, and obviously to improve how the naming, and to make easier for developers to test. But essentially, we are going to have more helper utilities where you can set up accounts, even assign names, but also to immediately get the UTXOs, even filter. Like, let's say I want 1 UTXO, I want 10, and so on.
Before you go, I want to just kind of stuff for some developers here. So if you are a little bit new to developing with Bitcoin, you use the EVM. What's the equivalent of a UTXO? Like, so what does that actually mean, and how is that? What's similar to that? I guess in EVM land, so people understand.
Yes, so I'm going to give the analogy that actually Greg, that is present here, he gave to me. And I think that was a very, very nice explanation. But yeah, if you're coming from the EVM world, like I do, you know that you can simply say, let's say, to get the balance of a particular person, you just call the JSON RPC and you can get the balance. Or even if you are in a smart contract, let's say a token, you have access to this balance of a particular token, so you can get a particular address. But in the Bitcoin world, the best analogy is to imagine that you have bills, and these bills are of different value. So let's say someone sent me at some point on time a UTX, a transaction that is saying that I can spend 1 BTC. So that's a bill of 1 BTC, and that is a UTXO. So that's why here we are generating. So the analogy is that we are generating bills. Then I want to get those bills to be able to spend them. Does that make sense?
Yeah, that's a great analogy. I like that. Yep.
And I think when you want to spend these, say you have like 2 UTXOs of 1 Bitcoin, and you want, say, like 2 Bitcoin or some like non-decimal amount, then you have to like merge these UTXOs, right? Or send like multiple of them.
Yes. So in this example, here we are listing the UTXO, then I get the first one, and then I create the input. So this is, I'm going to spend this UTXO, but also, like you mentioned, there could be certain, it's like I'm paying with one BTC, but I need some change. So you need to also program that UTXO and add it to the transaction. So in that case, I'm saying, okay, I'm going to, I create the input because, okay, so a small break, a BTC transaction contains the following information. You have inputs and outputs. The inputs is, you need to tell, it's like, okay, I have my 1 BTC bill. This is what I can spend. And then you need to say, okay, what is the output of this bill that I'm inserting in a vending machine, let's say? Well, it is more complex than a vending machine, but yeah, let's say you want to spend that, and then you need to specify the outputs of this transaction. And one of these outputs could be, okay, I'm getting 5 cents from that particular bill. Does that make sense?
Yeah, I'm with you. Yep, makes sense.
Okay, so yeah, and then we are using here so since I'm reading that UTXO from the Bitcoin core node, so it's basically you are interacting directly with that. I need to extract a bit of information like the transaction ID and other information, and then I create the inputs, the outputs, and with that input, with that set of inputs and outputs, in this case, it's just simple. It's just a single input, but then we generate the transaction using the Omni library. Now, in the BTC world, there are these type of scripts that are kind of a way to verify inside the Bitcoin core node. And we also have different types of addresses, like legacy addresses, SegWit addresses, and so on. So depending the version that you are using, you need to encode different information that is going to be added to the transaction that is going to be used to be verified by the node. So in this case, because this example is pay to witness public key hash, we basically need to create a witness. And how do we do that? We use these utilities. And then, okay, so before going deeper, in the BTC world, there is something called SIG hash. And if you are coming, I mean, by the way, this is very, very low level. But yeah, in the BTC, in the EVM world, you basically have a transaction hash that is signed by, let's say, in this case, you can sign it with the MPC signer, but also if I have my private key, I can sign a transaction hash, and then I can propagate this to an Ethereum network, let's say to an EVM network. And because I sign it, then this is going to be verified in the EVM, right? So in the BTC, something like that exists, but instead of a transaction hash, I think an analogy could be a SIG hash. And this SIG hash could be generated in different ways, depending the version of the of Bitcoin or the Bitcoin transaction that you are using. And in this case, we generate the SIG hash in this way. I use the Omni library and I say, okay, I want to build for signing Sedgwick, which is building the SIG hash for Sedgwick. And then it generates that SIG hash, and that SIG hash is the one that we need to sign. Okay.
And how difficult is it for someone to swap between like SegWit and legacy type transactions, or do you recommend that someone just stick with like SegWit?
Yeah, so Segwit is an improvement to the version 1 of the Bitcoin transactions. In theory, it's cheaper for people to do it. To be quite frank, I don't see any reason why. I mean, there might be some particular reasons for people to choose legacy, maybe for some wallet restrictions. But if you are starting in this BTC world and near, the recommendation is just go directly with Sedgwick, and that's it. Yeah. Mm-hmm.
And I think if you're running it on like a Bitcoin testnet, it's a lot easier. Most of the faucets support SegWit rather than legacy wallets.
Yes, so that's another. Yeah, definitely, that's another reason to better use Sedgwick. So yes, we generate the SIG hash, and this is something that we also do because we are basically doing the full encoding, but we are taking a lot of inspiration from other libraries like Rust Bitcoin, and basically we need to compare that what we are doing is analogous to what they are doing. So here, this is because remember that this is within the Omni library. So this is an integration test. We do, I finish here doing it with the Omni library, but then I continue doing with the Rust Bitcoin. And I basically repeat the process, but the idea is that at the end, I'm basically comparing the encoded that the SIG hash by Omni and the SIG hash by Bitcoin by the official Bitcoin library are the same. So in this way, we are more secure, and okay, we feel yeah. Honestly, the other day there was someone telling me, oh yeah, because we have this for all the libraries. So even for EVM, we are doing the comparison against Alloy. For Neo, we're also comparing against Rust Primitive. So yeah, we know that the encoding is okay. And it's funny because the other day a person told me, I think there is a problem with encoding. And I'm like, no, I'm sure the encoding is good. And the error turns out to be another thing. I mean, definitely there can be errors, but that particular case, I saw the payload and I was like, I'm sure it's okay. But obviously that's not like arrogance. It's simply that we are adding some tests here, and yeah, this gives you just a lot of peace of mind, and yeah, we feel very very happy because of that. Okay, so
You
that
can
was
tell
one.
that this Bitcoin file is quite a bit larger than like the EVM and near one.
Oh yes, yes, it is very large because we added more tests. Also, we are adding here um, pay to public key hash, which is the legacy one, and pay to witness public key hash, which is using Segwit, and we added more tests, and I think more tests are coming. But yeah, also for debugging, we are adding a lot of utilities because it's difficult for people to debug. If there is an error, it's super complicated. But little by little, we are finding strategies to do this in a better way. So yeah, here I repeated a bit the process of to calculate the SIG hash. But yeah, you have the SIG hash, then you sign it. And here we simply use assign EC DSA, which is simulating that. I mean, this part right now I'm signing locally with the private key that the address that I generated is giving me. So this private key is really inside a node that is currently running in my local environment. So I have access to that private key, and then I can verify. But here what we are doing in the so the example is still not updated, but I'm adding an example here where I'm basically signing here. I'm signing in the here you can see that I'm calculating the SIG hash in the near contract. So this is a near contract where I'm generating the SIG hash directly, and then I'm signing that in the contract. But here, but this is still. I mean, I need to clean a bit the code, but yeah, it's working actually. But here, this is yes.
Sorry, this is the part where you first showed, and this everyone's aware of. Like, this is where the MPC comes into play, right? This is that connection between leveraging the MPC and what you're doing here in this code, correct?
Correct. Yes. So I want to emphasize that here I'm signing with a private key that I have in my local Bitcoin core nodes. Okay. Remember that I'm running in the beginning. I started this Bitcoin node locally, so it's running there, and then this Bitcoin core node is also giving me some accounts, but this account also has a private key. Then here I'm signing, but if I'm signing here with my private key, really there is no difference if I'm signing in the MPC signer, which is what I'm doing here. In this example, let's find it. I calculate the SIG hash, and then I'm calling the near contract. Here I'm creating the near action, and I'm calling sign SIG hash. And then basically the signer, I get the result, and I send the transaction, and I extract the information. But I have a signature that is also ECDSA, okay? But yeah, that is very important. I can sign in the MPC signer, I can sign locally. For the Bitcoin node is the same, okay? But for us, it's a very good first step, because imagine you are trying to do a library and you are trying to interact with this external component, the MPC signer. So it's adding more noise to your local development and makes more complicated. So you go step by step. And the first step, okay, I understand the principle that I can sign remotely, I can sign locally, but at the end of the day, it's a private key, and and I'm signing with the ECDSA, and that's it. At the end,
So
I get a signature.
basically, you're like proving here that signing with the MPC and using the library is the same as just like signing with a standard Bitcoin private key.
Exactly.
And so are you suggesting that when people are like developing in a local environment, they should be they can like safely assume and use the local private key in their testing, and then once it's like ready and they're ready to test it on like testnet or something, they go ahead and use the MPC?
So that depends. I mean, yes and no, it depends, because if you are talking about a near contract that is interacting with the MPC signer, once you call, let's say here, once you call this function that is calling the MPC contract, you are basically signing over there. And then you need to deploy this to a testnet. But I'll show the flow that I have here, because actually this example is quite good, because I'm basically deploying this contract to testnet. So this contract, Bitcoin signing with propagation, I'm developing my new contract, and I create an integration test where I'm starting my Bitcoin node. Then I deploy, actually, where is the flag? Where? Yeah, here. You can see that if I say deploy, I'm compiling this contract, deploying to a testnet, and signing in the testnet. So that is also possible. Now, I know that there are some efforts for some, I know a particular team that is working in an MPC signer to be able to work locally. So you can be working with your near contract locally, and you are going to have a testing environment like this one, and you basically can point with your near contract locally to that local instance of the MPC signer. So
In like near integration tests, or?
Yeah, in a near integration
Oh,
test.
nice.
Yeah, but
Nice.
okay, so just to answer your question, it depends. If you need to sign outside, you can always assume that either I control the private key or I sign remotely. But if your logic is calling directly the MPC signer here, then you can use a pattern like this, where you basically deploy you are kind of working locally with your Bitcoin node, but signing remotely. And then the result is propagated locally. So you test that everything works perfect. Does that make sense? And actually, this example, the one of the Bitcoin propagation example, is this exactly. I create my BTC locally, I deploy my near contract, and then I also call the MPC signer. Okay. Actually, this example would be like this. Sorry, because I forgot testnet. And here you are in your local environment, and you have the BTC node plus the near contract source code that you are developing. But in the integration test, I deploy to testnet the near contract. And of course, when you deploy to testnet, you have that the near contract is going to be here. No? Let's say a contract dot testnet. So your contract is going to be there. And then this one is going to call the MPC signer. And this result comes here, and you deploy here. So it's kind of a bit tricky, but I think right now this is the best way that you can develop BTC apps in there, because you have control of the UTXOs, and you are testing the real contract, developing in testnet, and using the MPC signer. Yes.
Does this pattern apply to when you then move to production?
I think you could do that too. There is really nothing stopping you to sign this MPC signer basically could be mainnet. But I mean, I guess the best answer always is it depends. Like when you say move to production, like why would you like to test in production?
Not test, but is this, if I am developing and this and I'm ready, I say, okay, how much of this setup needs to also then move to mainnet?
Okay, the only problem is, okay, if you're doing testnet, you would be basically spending real near money here in order to get signatures just to deploy in a BTC node in local mode. So that wouldn't, I mean, you could do it if you want to, but I guess, I don't know why would you spend real near
Right.
to deploy in a local testnet.
I think
But
maybe what you were trying to say was like how much needs to change to go from like this local node to like
oh,
real Bitcoin. Is that
Yes.
what you were
yeah,
saying?
yeah, no, nothing. I think that's what I like this environment because this is the closest thing to reality. Like right now,
Mm.
you are deploying here, but I'm gonna show you here when I propagating the transaction. So here, this is the BTC client, but in it is right now in rep test mode, but it could be in another client because at the end of the day, what we get from Omni is this encoded Omni transaction that is a payload that you can propagate. So you can give this to your brother, to your cousin. And, okay, here is the payload. I already signed it. You propagate that to any network. Well,
So you
in this case,
just so it's just like the relaying step that basically changes, and this is like happening off chain anyway. Like you're not going to relay it from the
yes.
contract, right?
Although there is one particular thing to mention that when you create addresses, you need to specify for which network in BTC because then they change a prefix. But if you, let's say, change here the code and generate the BTC addresses for mainnet and you propagate to a BTC client, and that's what we are using the closest, send row transaction. This is like the lowest level you're gonna get to send a transaction to the BTC network. But we are doing like this because we understand that number one, actually, I think is the only way to do it. Well, not the only way, but it's the lowest level possible way to do it. And you are sending a row, you are sending a hexadecimal to, and then you just propagate to any BTC client.
Got it.
Cool.
And yeah, so I think something that I didn't mention is, okay, we get the signature, and then we simply create the witness. We use still Omni to build the transaction with the witness, and then that's it. We propagate that. And that's pretty much the process that we are currently following. You are going to find the same similarity here in this example, but this example is more elaborated because, and this is another decision that we took for this example. We are using the near JSON RPC client. Like what we are trying to do is basically the closest thing, like how are you going to communicate? And here you get the near JSON RPC, and we are doing a real transaction. Like here, you're gonna see I'm calling the smart contract, creating the transaction, calling my near smart contract. I sign and then send the transaction. And then with that information, we do basically, okay, get the signature, then build the witness, and then propagate the transaction to the BTC network. So this is the same approach, but here it's more elaborated because we are interacting with a real contract in here. That's why you see the calls to the JSON RPC client. But also, we're also signing with the MPC signer. I hope that
I
wasn't very confusing.
It's a lot of code, but it's really cool. I think to zoom out, like this is all written in Rust, right? And I think
Oh
the
yes.
apart from Rust being a beautiful language, I think the main reason it being in Rust is that near smart contracts are primarily written in Rust. So you could do like all of this on the front end and like request a signature from the NPC directly from like your account just in the front end with no sort of proxy contract in between that's generating these transactions and UTXOs. But I think the powerful thing of having this logic in the contract is that you can implement smart contract logic like on top of Bitcoin. So you can have some sort of logic that decides when like a transaction can be generated, which allows you to like lock Bitcoin up or like sell an ordinal on a marketplace all on top of NER.
Yes, that's totally correct. And I just want to emphasize that we're still early. The tooling is evolving, but we are going to add these omni testing utilities that are going to reduce a lot the boilerplate. And yeah, we're trying to make developers' lives easier, easy.
Yeah, and I've actually I've messaged Edson quite a bit about this library because I've been playing it around with it on like the near side rather than the Bitcoin side, and I've loved using the library, to be honest. After getting to learn it, I had a few hiccups, but now like it's pretty easy to use.
Oh yeah, by the way, I'm already implementing your feedback. So yeah, thank you for
Nice. I'm glad you're listening to my feedback. It's hopefully valuable then.
Awesome.
100%.
But yeah, awesome library. I love the work you've been doing.
Thank you. Do you guys have another question?
No, not right now. Where's the? So I want to make sure. Oh, it's the wrong person. I want to make sure we
Not
share
wrong.
the right GitHub here. So it's
yes.
GitHub Omni RS, correct?
Yes.
Yeah, and
Omni
if you
RS.
look if you're on Twitter and
Okay.
you look on the in like the comments, you'll see I've pinned well, not pinned, but I've commented the library down there, so you can take a look if you're on Twitter.
Great. Cool. Greg.
Yeah, let me present my screen.
Yeah, well, Greg's going to load up. There's plenty of bounties here related to chain abstraction and building across other chains. And so great opportunity for the hackathon, but also, too, if you're just interested in building with this stuff, this is all available here. So, yeah, take it away, Greg.
Okay. Yeah, so I'm going to go over a lot of the same stuff that Edson did, except from an application developer perspective. And so I have this BTC example that is sending Bitcoin transactions with a near wallet in the browser. And so it's pretty simple. I'm going to give a live demo in mainnet. But yeah, it's pretty simple. Basically, you can choose between SegWit or Legacy. You can choose the path, which changes your address. And then I've got a balance of 5,400 Satoshis. And so I'm going to send a small transaction to myself. And so this is signing with my near wallet. Oops, that didn't work. Let me try again. Okay, so there's the, let's try this. Okay, this looks good. So constructed the transaction. It got the signature back from the MPC using the Near wallet. It finalized the Bitcoin transaction, and now it is broadcasting it to the Bitcoin mainnet.
Well, that's going question that I know I've heard people ask before. So,
Oh no.
Yeah, failed again.
Even
promise.
as
Always on live demos.
oh,
Yeah.
of course. So
Is
even
this actually
as
mainnet?
It is mainnet, yeah. We'll try again. This worked just a minute ago.
Sorry for cutting you off, Joe. I was just surprised this was mainnet.
Well, it was working earlier. Let me show you the one that I just sent. So this one is something that I just sent from this address. So it does work.
yeah.
But yeah, I was going to walk through the Bitcoin code and the parts that confuse people. So in a lot of ways, like we're building like a Bitcoin wallet because we need to generate the addresses and we need to like manually create these transactions. And so like over here is the KDF script. This is what we use to generate the Bitcoin addresses. And so my like React code just calls generate BTC address. And depending on the path, if it's testnet and the address type, it'll generate a Bitcoin address. So that's the part. Oops, that didn't work. So like, oops, doesn't like legacy. But yeah, this is like changing the path. It's calling that method.
Mm-hmm.
Then when you send the Bitcoin transaction, the React code calls this method, get and broadcast signature. And so something that kind of confuses people sometimes is there's actually like, it constructs the Bitcoin transaction twice, and there's a dry run. And so the get signature is the dry run. And this is what initiates the near transaction and actually like gets the signature. And so the way that this works is you construct the PSBT and does all this stuff. Creates a partially signed Bitcoin transaction. That's what that means. Which just, it's like an object that has all of the Bitcoin inputs or all of the UTXO inputs and the outputs. Because like Edson described earlier, the UTXO model is like, it's more like cash than an account model in Ethereum. And so you have like all of these like dollar bills, except for they can be any denomination. And so like right here, you can see I have a UTXO with 32,000 sats. And so that's what this construct PSBT object is just doing. It's inputting that UTXO, and then it's adding the output, which is the address that you want to send to. And so once you have that transaction constructed, you can, this is also kind of confusing. So we're using Bitcoin JS lib, and the way that we get the transaction hash is we pass in this like key pair object to the PSBT sign input async. So this is just the object that contains the public key and this sign method. And so we need to do it this way because this is how you get the transaction hash from Bitcoin JS lib. And so once you have the transaction hash, you create the payload, and that's what you need to send to the MPC to get the signature. And so once we have the signature, like right here, then we can actually finalize the PSBT and send the transaction. And so it goes over to broadcast method. And so here we're passing in the signature manually. Typically, this like sign method would call like a local signer, but because we're using like a remote signing service, we have to break it up into these like dry run and then like this broadcast run. So once we have the sig, we essentially pass in this like fake signer. It's not calling anything. It's just essentially returning the signature that we received in the first run. And then once everything is finalized, we can broadcast the transaction. And so it sends this to Blockstream. And then it returns whether or not it failed, which is what happened earlier, or it returns a link to the like the successful transaction. And that's pretty much it. Do you guys have any questions?
Cool. I think the front end, once we've talked about it in like a contract setting, I think the front end becomes a bit more simple, you know. So I don't particularly have any questions myself about this. Any from you, Joe?
No, I don't have any questions. I do though. Just curious, like your thoughts, and doesn't have to be overly specific, but like, where do you start to see people actually implementing this into products? Is it just purely different DeFi things, or can you start to actually build apps that are leveraging Bitcoin in different ways?
Yeah, you could absolutely build an app that interacts with Bitcoin using something like this. Anything that would involve like interacting with the Bitcoin network, and you want to use like near on top of that, this sort of approach could be useful. It's sort of like provides a way to like write smart contracts that write an app that interacts with smart contracts on the near chain and then can also send Bitcoin transactions.
Yeah, I think one of the most interesting use cases I've seen so far, I can't remember his name, but one of the devs at Pagoda was creating a like Bitcoin wallet, but all you need is a Google account to sign up, and it like generates a proof that you have the front end generates a proof that you own like this Google account, which then you make a call to like a near contract to verify that you own the Google account, and then from there you can sign like whatever message to the MPC service through the contract with like any Bitcoin transaction. So you can like send Bitcoin to anyone just by having like an email address. And I think, yeah, that's just like one of the many interesting use cases.
Yeah, exactly. Yeah, it opens up a ton of use cases. And you notice I actually got a successful transaction here.
Let's go.
Yeah, so here it is. It actually works.
Yeah.
And saved fees on SegWit.
Was this a mainnet one?
Yeah. Yep.
Nice. How much gas was it? Well, it's not gas in Bitcoin, is it?
1,100 Satoshis. It looks like I'm overpaying too. I could tweak that.
Nice.
Another question, just to clarify for people who are new to building on this. So maybe they've done chain abstraction with just EVM, or maybe they're just new to this whole thing. From a timing standpoint, everyone usually is aware that the Bitcoin network is a lot slower because it's doing proof of work. How does it all fit into what you're doing here, and how this works with chain abstraction?
Sorry, could you say again?
Sure. So the timing of making calls and using a network. So if people are new to working with Bitcoin, and maybe they at least understand that because it's proof of work, it's a little bit slower for confirmation messages and things like that. But how does that fit into this? Are they still, let developers know they're still bound by having to go through that? Are there some things that are happening here in the back end that are speeding anything up? How does for people who are new to this?
Yeah, absolutely. Well, yeah, coming from like a chain like Near, Bitcoin transactions are a lot slower. You saw how long it took. It was like 10 something seconds, 15 seconds for the Bitcoin part. But the Near transaction probably only takes about a second or 2 seconds. So I guess it's just something to be aware of. You're going to have to make sure that your code can handle like a long timeout. At times it can, like various parts of this can time out too. So it's just something to be aware of.
Yeah, I think like a model some people are trying to work towards is instead of sending like Bitcoin transactions themselves, you have like an account with Bitcoin on, and you send like access to the account through the MPC to different people. So then you're like sort of sending Bitcoin, but with Near's like finality and gas, so you can sort of avoid some of those problems. But then you're restricted by well, the accounts somewhat become UTXOs themselves, where you have to like merge Bitcoin from different accounts and split it up if you want to send an amount that isn't the amount that's on that account.
Yeah, exactly.
I think it becomes more interesting with things like NFTs, and I don't know anything about. I keep hearing the word runes. I don't know what a rune is, but
Yeah, runes and ordinals.
do you actually know? I'm familiar with what an ordinal is, I think, but do you actually know what a rune is? Either of you?
It's like tokens. It's a way to build tokens on Bitcoin.
Right. What, like
So
fungible tokens?
yeah, exactly.
Oh, okay, cool.
So yeah, you could use an approach like this to build a runes or an ordinal app. You'd be able to use a Near account, and you'd be able to interact, like purchase a ordinal or rune, or make trades. Whatever you want.
Awesome. Well, Greg, I really appreciate that you taking the time today, walking us through all of that. And what's the best place for people to go to ask questions if they have any?
I'm on Telegram, and on GitHub.
Perfect. So we're just right into the different repos. Just jump in, ask questions.
Yeah, I'll drop a link to the chain abstraction chat below in the Twitter comments, so you can join this chat if you have any more questions about building this sort of stuff. I'll try and help, but this Bitcoin stuff probably won't be able to.
Yeah. No, perfect. Great. This was super helpful. Definitely appreciate Greg you taking the time. We'll add this stuff all to the show notes. People are watching this on a replay, and kind of get involved. And we encourage people to start building on this. Thanks for your time today, Greg.
Thanks, guys.
Thanks.
Thank you.
So again, if you are not already signed up, you can leverage all of this stuff that you just learned here in the Redacted Hackathon. It is going on for a few more days. There are tons of great prizes here. Here, I'll bring up the page real quick. We can go through because there are some chain abstraction related ones.
I think there's a
But
lot of chain abstraction ones, isn't there?
yeah, there's a lot of different stuff you can do here. So there's best of chain abstraction. There is some stuff around DeFi here. So obviously this all fits into that. Proximity has their own separate bounty as well related to this. There's a bunch of stuff that, again, you can start to mix and match here of leveraging different pieces. So you could take maybe the workshop that we saw at the end of last week with BitDay, using an agent, build an agent tied into something that's doing with like the Omni library here, and now you're really mixing and matching, and you're eligible for all the different categories that your product fits in. You can leverage, and so you can actually apply to all of those, win multiple prizes, which is really exciting. If you sign up, you have until the pretty much the end of the working day, depending on where you are in the world, on October 31st. There are so many projects, especially if you go back and you look at some of the different AI agent ones and things like that, that you can get done in a few hours to just get started. So you could spend a day or two and get something ready to actually submit. There's $700,000 in prizes. It's a great way to get involved and learn more about the Near community and stuff like that. And there will be support all the way up until the deadline and beyond through our different support channels. And all of those are all listed here as well. Off of Dev Post, if you go to resources, everything is right there for you. Come say hi in the different Telegram groups and start building. Owen, you want to end with anything? This was another good workshop here around building with Bitcoin.
Yeah, I learned a lot on this one. Really interesting stuff. Bitcoin is quite complex, I would say, to deal with, and not that many people building it. So I think there's some cool opportunities there of what you can build. And I'll be really interested to see if many people build with Bitcoin on this. Like I say, I'm not too familiar, so maybe people are going to come up with stuff that I have no clue about, and it would just be awesome.
Yeah, no, for sure. We're definitely excited to see what comes out of all of this. We will be back again our normal time Thursday at 4 p.m. UTC. We have a kind of combo episode workshop, building with privacy. So Sandy from Calamero will be back on again. If you've been watching the Fridays with Froll, he'll be back on. It should be a really fun one, talking about building around privacy and everything else like that. That is Thursday at 4 p.m. UTC, same place. But until then, keep building, and we will see you Thursday. Bye, folks.